we have an fractions problem. In order to add fractions, the denominators need to be the same. So what we can do is multiply the first fraction by the second denominator. And if we multiply the denominator by something, we also have to multiply the numerator by it. And the same thing on the second fraction. If we need a common denominator, we can multiply by the other denominator, which is the x plus 3. Excuse me, x plus 3. And if we multiply the denominator to keep things the same, we'll need to multiply the numerator as well. Okay, so generally from here, what's best to do is to distribute the numerator but leave the denominator in a factored form. So if we multiply x times x plus 5, we get x times x is x squared, plus x times 5 is 5x. So that's the numerator of the first fraction. The denominator is x plus 5 times x plus 3. We'll just leave that in a factored form. And the other numerator we need to FOIL. So the first would be x times x would be x squared. The outer is x times 3, which is 3x. Inner is 2 times x, which is 2x. And then last is 2 times 3, which is 6. And then we can write the same denominator, but leave it factored. So then from here, let's simplify just a bit to make this x squared plus 5x. We don't have any like terms there. So we'll just bring it down. But then the 3x and the 2x are like terms here. So we can add those two terms because they have a common x. And that will be x squared plus 3x plus 2x is 5x plus 6 over x plus 5 times x plus 3. Okay, so from here we will add the numerators together and the denominator stays the same. So x squared plus x squared is 2x squared because they're like terms. 2x squared. So we add the coefficients. And then 5x and another 5x is 10x. Then we don't have another constant term, so we'll just bring down the 6 and pull that down. Times x plus 3. And that's it. We could factor the numerator pulling out a 2 or something, but that should be the final answer.